Hello everyone, this is Atul with Sai. So welcome back to the channel. Today we are learning solid principle D, which stand for Dependency Inversion Principle, DIP, one of the most important principle for scalable and testable application. And yes, we'll explain it using a real banking application in C#. Now I am opening Visual Studio. So most developer thinks using classes correctly is enough, but real problems start when one class tightly depends on another class. Okay, so what is the dependency inversion principle? Its high level modules should not depend on low level modules. Both should depend on abstraction, and abstraction should not depend on details. Details should depend on abstraction. In simple word, classes should depend on interfaces, not concrete implementation. So I will show you the bad example. So problem scenario is like our bank account service directly depend on concrete email service. So now I'm creating one class. So I will show you the bad example first. Then I will show you the good example, how we can achieve the DIP by using the interface. Public class email service. Okay, we have created one class, email service class. Under that we have one method, send email method. Public void send email string message, and we have send email message logic. Now we'll create one more class, bank account service class. Public class bank account service. So under this we have, so we are creating a instance of email service class. Email service underscore email service equal to new email service. And we are creating one method, public void create account, and under this method we are calling email service class. Okay, so you can see bank account is created and your bank account has been created. So we are sending the send email notification. So now you can see what's wrong here. So it's a tight coupling. So you can see we have created one object, email service class object. So this bank services depend on the email service class. So it's a tight coupling. Cannot replace email with SMS or WhatsApp. So we cannot replace this class. So it's difficult to test, and breaks existing code and violates dependency inversion principle. So if you are using like this code, okay, so in impact in real banking app like if bank wants to add SMS alert, so you need to changes here. So there is a huge possibility to break the existing changes. So once you did some changes here, then you need to retest the application. So there is a time consuming process. Okay, So you must modify bank account service every time. You need to modify this bank account service every time. Okay, so that's dangerous for production system. Now we'll delete all this bad example code. Now we'll replace this code with the good example. So that's follow the DIP. So good example is DIP. First thing is that loosely couple. Okay, so first thing I'm going to create one interface, public interface iNotification service. iNotification service. Under that I am declaring one method, void send string message. Okay, so we have created one interface and we have declared one method, send method. So now I am implementing the concrete service. Okay, so public class email notification, and we inherit with iNotification service interface. Okay, now I'm going to implement that. So here in this interface we have declared this send method, and in the concrete class we have implemented that send method. Now I'm creating one more class. The class name is public class SMS notification service, and again same we are inheriting with the iNotification service interface. For a same I am implementing the send method, public void send string message. console.writeLine SMS notification message. Okay, so we have created one interface, we have created two classes, and we have inherited this interface to the email notification class and SMS notification class. So now high level module depends on interface. Okay, now here I am creating a one more class. That class name is public class bank account service. Okay, bank account service class, and under that I am going to create instance for iNotification service interface, private read only iNotification service, and we have created object of that iNotification interface. Now I am creating one constructor, public bank account service. So you can see we have added the dependency injection here. So you can see we have under that constructor we have, in this constructor we have added the dependency injection for iNotification service. Now I am creating one more method in this class, public void create account Okay, so bank account is created successfully, and we have called that iNotification service dot send method here. Now so we need to call this in main program.cs class. So I will show here. Now here I am calling I'm creating a interface object in this main method. Okay, I notification service equal to email notification service, and I'm also creating a bank account service class interface, class object. So we have created I notification service object here and we pass that notification service object to bank account service in constructor. So we have the parameterized constructor. Okay. So you can see we have parameterized constructor here. Now here we are calling bank account service dot create account. Okay, so benefit of using this dependency inversion principle is like this is a loosely coupling. Anytime you can change here for SMS or email or WhatsApp notification. Okay, based on that you can easy change. So it's a loosely coupling. It's easy to extend feature. In future, is there any new notification introduced, then you can easily extend the features. Easy unit testing or mock interfaces. You can easily mock interfaces by using XUnit or supported tested features. Okay, and open for future changes and enterprise ready architecture. So this real banking impact is like you can add a new notification type without touching the core logic. Okay, without touching core logic you can add the core logic, notification type core logic. Then it's a safer for production changes, it's a faster future development and clean architecture. So like real world example is like bank doesn't care how notification is sent, it only cares that notification is sent. Just like ATM doesn't care which bank card and charger doesn't care which brand phone. That's a dependency inversion. So the final summary is like the bad design is like class and concrete class, and good design is class inherited with interface. So golden rule is for DIP depends on abstraction, not implementation. So thank you for watching this video. If you found this video helpful, like, share and subscribe. Comment DIP if you understood clearly. So next video, complete solid principle with real project. So see you in the